was just versions of the old exam review topics. I know there's a lot of material here. I tried to narrow it. I tried to narrow it down for you guys with this exam review and tell you basically the most important things that were on here. I can read the final exam to you. I have been known to do that. It's very vague when I read it. Where are we at? So where you were getting to was right about here. We just finished the BJT. Things that I put on here, I will kind of highlight things I'm thinking about. We only had 2 exams in here. Oh, this is the diode stuff. Why is this just diodes? Why is this going this way? Sorry, I'm just confused about the order of my slides. Diodes, homework and slides, first, okay. Well, for some reason, diodes got put up here. Let's put it where it belongs. Where does it belong? Before semiconductor. There's about 10 things on different topics I could ask questions on. That's way too much. Am I sharing the screen? Or did I minimize you guys? Let's see what happened. I have no idea what just happened. Okay, we're back. I'm recording. I am sharing the screen. Okay. So let's go first order circuits. Probably a first order problem on here. Let's get something bright. Oh, so it shows up. First order problem, just a basic circuit problems. Don't worry about the rest of these. The big thing we're worried about here are these throwing a switch problems. Draw a circuit for t equals 0 minus, solve for the initial conditions. There are examples in the practice exam. There are examples in the slide solutions for this. And sketch the function. So that would be something that I'm likely to put on the final exam. I know me. Second order, something like this. This is something I'm likely to put on the final exam. It may be just pieces of this problem, like one problem with pieces, or it may be a really simplified version of the whole thing. Laplace transforms. So finding Laplace transforms. Be able to do that. No, not this. Don't worry about that. Find Laplace transforms from functions. Be able to take inverse Laplace transforms, which means do a simple partial fraction expansion, and then an inverse Laplace transform. Either this, either A or B. Okay, that's what I care about with Laplace transforms. Get that far, you can get through 340. You can start to understand 348. Bode plots. Finding, no, I didn't do that to you guys. Drawing magnitude plots from a function. Yes. The phase plots are too hard to grade. And filters, no. Well, sort of, maybe. Op-amp problem. This is important. Calculating power, voltage gain, and current gain in dB. So I've narrowed it down considerably. Okay. Next slide. Circuits in the S domain. I know what I care about here. I care about op-amps. Okay, so look at the exam 1 problem. Yeah, it was on exam 1. Exam 1 op-amp problem, which is also on, I believe it's like homework 6. It's the op-amp problem on the homework. So look for that. That's what I care about there. There's reasons for this because I want you to be able to pass your senior classes. I want you to be able to work. Diodes. This is a possibility. These rectifiers and limiters that we talked about in the first part of the class that's on this recording, that's a really good thing. I gave you another diode circuit, and I think I've tortured you as much as I'm going to do with that. So until we get to ESD protection, at which point it's just like if the voltage gets too high, the diode turns on. Okay, so what I care about there is being able to use the current equation and those rectifiers and limiters, things I haven't gotten to yet. Semiconductor physics, that was painful. Let's not do that. We'll get more of this. Don't worry, we will get more of this. If you choose to take 490 in the spring, we'll get more of that. What you really need to know. MOSFETs, yes. Finding the DC operating point, that's a good thing. Finding the operating region, there's a lot of examples of that on exam 2. Remember that PMOS and NMOS have different rules for the operating region, but I can use the same currents. Be able to calculate GM and RO. How can I get that all into one problem? So yeah, I care about MOSFETs. I teach 380. So, people from the outside, you know, like real engineers who come and talk to me, they want to know what I teach, and I just say microelectronics. I teach the MOSFET class. It's like, okay, they know where I'm at. Standard CMOS, yes, I care about that. I'm not going to worry so much about these things. Just be able to draw the circuits and analyze standard CMOS circuits. So let's make this a little bit simpler. We didn't get to this on exam 2. Yeah, it would be worthwhile for getting through exam 3. Go through, there is an example problem in these slides. There's another example problem in the exam 2 review slides, probably the second part, which is like one of your homework problems. Understand those. And BJTs, the most important thing I care about is this right here. And that goes back to that one slide I keep pointing to and saying, gee, I got everything on this slide. There's 4 equations and 4 equations, and there is active BBE equals 7/10 of a volt. If you know that and you can apply it, you can use Ohm's law, you'll probably be okay. Saturation, which we don't use too much anymore, because that's for digital circuits, and they're not good digitals. They're better analogically. VBE and VCE equals 0.2 volts. Okay. We're done. Any questions? I'm exhausted. I'm going to stop sharing so I can check the roll real quick. Who am I looking for? I'm looking for Mubarak. We don't have any extra. We don't have another.
Yes, I'm here. I'm here.
Oh,
Mubarak
you're here.
is here.
You're here.
Yes, I was late for 2 minutes. I'm sorry.
That's okay. Lane. I don't see Lane. He'll probably watch the video. Jordy. Okay, I don't see Jordy. So that's it. Jordy and Lane. And you guys will probably watch the video. Just send me an email. Okay, any questions? Okay, good. I will be I'll be in my office. You can always email me questions, and I may even go into Zoom if I feel like it. It's not office hours, but I can do that. And I will be in my office next week too, on Monday morning. I get up at 5, so I'll probably make it here about 10. Lauren, you had a question?
Yeah, could we go over how you found VN for the BJT problem that we did?
VN.
I think.
Oh, okay. Yeah, let me go back to this thingy. Oh no, I killed it. Okay, that's okay. Share screen. Zoom, share screen, share. So, okay, I'll see ya. BJT problems. Right about here. So VN was we don't know what VN is. See,
Yeah.
VN can vary. VN depends upon how the temperature, the phase of the moon, and how the guy before you circuit is working. So generally what we do is we don't rely on VN being any one fixed value. We just find the gain. We find the ratio of V out to VN. And then if I know VN on that particular moment, I can calculate what V out is.
Okay. So in the circuit that we had for that problem,
Yeah.
would we find that ratio by doing like voltage divider or something
Well,
similar?
it's basically you have to do that small circuit model thingy. So
Right,
you've got
yeah.
R pi, and you got your little current source here. Oh, this is getting sloppy. You got your little current source here, and you know that VN is tied directly to the base. So VN over VBE, and this is grounded, is going to equal 1. Or VBE over VN equals 1. We just leave it as a variable because it's tied directly in there. Whatever voltage I have there will be VBE. And then the output, you get this parallel combination of resistors. You get the current source, which is GM VBE. It's going into the wrong end of this thing. So what you're going to get is you're going to get IS times that resistance will equal, wait, I just really messed up that equation. So this current source times that output resistance is going to equal the negative of the voltage. And the current source is GM VBE. And RO is whatever it is, whatever that resistance is. And I put a negative sign in there, that's going to equal V out. So V out over VBE comes out to be negative GM times the output resistance.
Oh, okay.
Yeah.
And then we just multiply those together like we did with the other
Yeah.
problem. And okay. All right, that's it. Thank you.
Okay, good. All right. Okay. Anything else? I'm going to wind a little bit.